Hello, everyone. Mr. John here from Air Team Institute with this week's Thursday Tidbit, where we're going to talk about modeling Reddit's The Button. Now, this is a little bit old, so people might not have heard of this, but more recently, Reddit, which is a social networking site, if you haven't heard about it before, revived this place project over April Fool's Day or starting on April Fool's Day this year. They had ran a similar thing from April 1st to 3rd, 2017, and this was a crowdsourced interactive image where users could modify one pixel every 5 minutes. So every 5 minutes, a user could modify a pixel, right? Maybe somebody else modified that same pixel. All kinds of different things like that could happen. And so in 2017, this image was 1,000 by 1,000 pixels. It started out the same way this year. It expanded then to 2,000 by 2,000 pixels, right? So these are million pixels and 4 million pixels respectively. So a lot of pixels there. Now, there's some interesting things going on with this. If you want to discuss that a little bit more, let me know in the comments. We can maybe try to do that in future Thursday tidbits. This one's more recent. You'll notice the images are a little bit blurry because some not so good things might be going on in those images too that I don't want to worry about here since everything was purely crowdsourced as well, right? But let's not get into those things, and I want to talk about a alternate project from 2015 that was referred to as The Button. So on April 1st, 2015, a blog post announced this The Button, which was literally a button on the website there. It had a 60-second timer, and anytime a user clicked the button, it reset the timer at 60 seconds. So it was at 60 seconds, it counted down to 0, and once it reached 0, the experiment ended. So as soon as that button reached 0, it wasn't like a second chance or anything, although there were some technical difficulties, but as soon as it reached 0, that experiment ended. So again, it was this crowdsourced type of thing. Now, actually, it was a little bit rougher than that there as well, because it is a little bit interesting that each user was allowed to press the button only once. So this is a little different than this interactive image that happened more recently. People could modify pixels multiple times, right? There was the timer that they had to reset for the 5 minutes for the image. But here, every user could only press the button once. So this is an interesting setup there as well, and a little bit easier to tackle. Well, we'll see it's more complicated than we might think, but the general question would be, well, how might you estimate how long it lasted? Spoilers, this happened 7 years ago, so we can look up the answer. I will tell you the answer at the end of this video. But I want to do a little bit of discussion with how you might estimate, what are some things you might have to think about, what is some of the math behind this that you might need to consider if you were trying to answer this question from scratch. Spoilers, it's not an easy question. So let's just start with a simple example that we're going to look at today. Suppose you have 10 users to press the button. Now, first of all, let's assume for this case, every user wants to press the button. Why is that not a crazy assumption? Well, that's just kind of a first step in any calculation, right? If you have 100 users and we estimate 10% want to press the button, well, now we're in this scenario. We don't even need to use the 110%. We just can focus on how many users want to press the button there. Right? And I don't want to worry about technical stuff, right? These are users at different computers. What happens if they both press it at the same time? Let's just assume that that doesn't happen. So suppose when it resets to 60 seconds, no one can press it from 60 to 55 seconds or things like that. So we don't have to worry about that for our modeling purposes here. So even if two users try to press the button at the same time, which we will assume could happen, that we'll just say only one goes through and then the other person has a chance to say, wait, let me wait a bit before I press the button there. So we could ask this question about how long will the button last? And a big thing we want to talk about here is asking whether the users coordinate in some way. Now, you could say yes, you could say no. We're going to somewhat assume here that the answer is no in a sense. And the reason that that's not super important, I want to say here, is that we can just assume that everyone is engaged in this, especially with the 10 users case. This isn't something that's going to be drawn on too long. So, right, maybe multiple people try. Since there's a buffer, if two people press at the same time, it's not like anything bad happens in that case. So let's just kind of assume they don't coordinate here. And we can say a little bit more about that later or next week too, why that might be good to think about. Now, right, if we kind of assume they coordinate, or if they all kind of press it right before the timer ends. Remember, with this buffer, we can assume that, okay, the first time the timer gets down right to 0, all 10 press, but only one goes through. So then the next time 9 try to press, but only one goes through. So even if we say they're coordinating or not coordinating, right, this is the best case scenario there. And this is pretty easy, right? If they're all pressing it right before the timer ends, this means they're all pressing it after 60 seconds. There are 10 users in this case, and so this will last 600 seconds in that scenario. Now, you could convert this into minutes, but let's just do seconds here. That'll be easy enough. All of our timer is in seconds and things like that as well. Now, pressing it right at the end might be a little bit unrealistic. So let's look at a slightly more realistic scenario. Right? Remember, all of the people want to press the button, but let's break these people down into some a little bit more paranoid or a little bit more risk averse people. So they're not going to wait till the last second. They're going to say, okay, 15 seconds or less, right? What if my computer crashes or something happens? Let's just be safe. I'm going to press the button at 15 seconds. The other half are a little bit more willing to risk it, a little bit more willing to go a little bit longer. They're going to press the button at 5 seconds remaining. And again, we don't really need to worry about coordination here, because the people, right, 5 people will try to press it at 15 seconds remaining. If they fail, right, or if multiple ones happen, only one goes through, things like that as well. But again, the calculation here is pretty straightforward. Half of the 10 people is 5 are going to press it with 15 seconds remaining there, right? So let's do that as the 5 people, and then that's happening after a little bit of caution here. That's happening after 45 seconds, and the other 5 are pressing it with 5 seconds remaining, so this is going to be pressing it at 55 seconds elapsed. So, little trick. Pull out the 5, 45 plus 55 is 100. So we can see here that the button will last 500 seconds in this case. So that's what we have here for our calculation with a little bit of room for error. Now, let's explore here our first question that we will revisit next week. This one is dealing with room for failure, or not maybe room for failure, but what's happening if we have failure there. So we want to allow for failure in this case. So Similar to before, 10 users, they all want to push the button. 5 will press it at 15 seconds left, 5 at 5 seconds left. So again, half and half. Half are a little bit more risk averse, half are willing to let it go a little bit further. But now let's bring in the situation where there's a 10% chance that a user fails their press, right? So I don't literally mean, okay, their mouse stops working or something, but in the grand scheme of things, right, if you ask people, right, and some of the stuff we'll explore in question 2 will make this a little bit more plausible, right? They may say, sure, I want to press the button, but maybe at some point they have to, right, take a phone call and they get distracted and then 15 seconds comes up, so they don't press the button there. They say, oh, I missed it, right? I missed my chance in that scenario. So let's try to take into account that there's this 10% chance that, they had to step away from the computer or something and they don't press when they said they would, or when they kind of are planning on pressing the button. Right? And so then the question here becomes, on average, how long will the button last? Now, I want to make clear here that this question is hard. I'm going to give a little bit of a hint. More so, this is going to tell you why it's hard. If you're into programming at all, this might be a good place to try to write a computer program to simulate this and do some estimations based on that. I'll also say verbally, it's okay to estimate here. We'll see what I mean by that a little bit on this slide. So let's just go through what's kind of happening here. So after 45 seconds have elapsed, now we're at 15 seconds remaining on the timer, right? So the timer says 15 seconds in this case. So let me just maybe draw that up as a little bit of a visual aid at this point. So the timer at this point is going to say 15 in this case. So timer reaches 15. We have some people now, 5 of them, half of them want to press in the button at this time. Remember, multiple presses are not worrisome there. So at least one of them will succeed, right? The bad thing is that they all fail. Each of them fails with a 10% chance. So the probability at least one of them succeeds is actually almost 1. So 1 minus 10% raised to the 5th power is 99.999% there. So for estimation purposes, right, we can assume this is 1. Right? So I'm not saying you need to do this up to, 3 or 4 decimal places in terms of percent, but notice that this will change from here, because even if we assume somebody succeeds there, now there's only 4 of them left the next time. Maybe that is still pretty much 1, which it is, spoilers. But then there's only 3 people left. So we're always getting rid of people because every person can only press the button once. Now, the thing I do want to make clear is that if they fail, right, even if there's this tiny chance or, right, getting larger as people are eliminated, if those 5 users pressing at 45 seconds fail, that isn't the end of things. Because if they fail, this timer keeps running down, but then after another 10 seconds, right, so here we would have then 10 seconds pass. Now the timer is at 5. And when that's the case, those other 5 users, who are the people waiting for 5 seconds left, they will try to press the button at that point. So you have this tiered system, and that's why it might make sense that some people try, okay, I'm going to press at 45 seconds. Okay, if I mess up, then I know that there's other people there that might try to press at the end or things like that as well. So this is stuff that makes it a little bit more complicated, and why I might recommend trying to write a simulation there. Or you can do some estimates, right? 10% is not that high, so there's actually not too many scenarios that come up if you do these estimates saying, okay, well, we're going to assume a lot of things are basically 100% chance. So we can ignore this scenario and say after 45 seconds, one of the 5 people presses the button. After another 45 seconds, another one of those people presses the button. Because a lot of these things will round to 100% when you're doing the rounding anyway. Okay, finally, let's have an easy question, which is more based on the real things that happened. So for the actual 2015 The Button, Reddit had roughly 200 million active users, right? Button was clicked 1,008,316 times, right? So this is the number of times that the button was clicked. So, right, roughly, right, 1 in 200. Not all the people participated in this case. And the button lasted 2 months and 4 days there. So that's kind of our actual amount of time it lasted. Now, just to compare some numbers and things like that, question, what is the average time remaining on the button when it was clicked? You know how many times it was clicked. We know roughly how many seconds. Well, you need to do some conversions there to see when the button was clicked there. Remember, it's counting down from 60 each time in that scenario. And explain a way the button could have lasted 4 months instead of the 2 months and 4 days. There are multiple ways you could answer this question based on some of the information I'm giving you here, but see what you could say and come up with for a scenario what could change or what behavior could change to make the button last 4 months instead of the 2 months it did. Little bit of references if you're interested more. There are pretty decent Wikipedia articles which I did use to help source this information for place and the button there. Otherwise, that will do it for this week's video. Thank you all for watching. We will answer these questions a little bit next week. And if you have other comments, thoughts, share new ideas with us in the comments below. Please like this video if you enjoyed it and subscribe to our channel for updates. Otherwise, I will see everyone next week. Goodbye.